Hi, my name is Scott. I'm a solutions architect with Vcinity. Vcinity is an AWS migration and modernization competency partner, and today we'll be looking into how we support AWS's move to managed analytics workflows. We'll be talking about a very important arrow in the quiver of a customer's strategy to migrate data to managed analytics, the movement of the data itself. Now, right off the top, let's start with what Vcinity brings to the table. A tool that enables you to move data at otherwise impossible rates, and in some cases, the ability to consume remote data without having to move it first. Here we see some target use cases for data movement: migration to the cloud for managed analytics, ingesting data that's been created at the edge and will be centrally analyzed, backing up and recovering between geodistant locations, and consolidating data centers, perhaps as part of mergers and acquisitions or a footprint reduction strategy. Now, in some workflows, you can use the Vcinity solution to achieve local performance using data that's thousands of miles away, federating distributed data sets for real-time analytics, bringing the compute experience closer to the user or application via edge compute without having to distribute copies of data along with the compute, perhaps cloud bursting or hybrid cloud strategies where you want to take advantage of cloud compute services without the time penalty to load data into those services. Now, if we step back and consider the life cycle of a managed analytics project, whether that's AI, machine learning, or deep learning, there are three basic steps: curate the data, model and potentially remodel the data, then take what you've learned and do something with it. But that first step is hard and time-consuming. Our customers have data everywhere, and they're concerned about getting the right data to the right place in just the right amount of time. They have data in silos, which makes it difficult to collect enough data to get good analytics outcomes. They have data that's perishable, meaning the data may be stale by the time you finish moving it. They have data with strict security and governance requirements and need to make sure the data is untampered to ensure sound outcomes. Vcinity delivers incredible technology to our customers, allowing them to quickly gain insights from their data, no matter the distance between compute and data. Quick recap: our customers have data strewn across assets, across data centers, across cloud locations, across enterprise sites, and probably further out than they'd prefer to acknowledge. Getting that data from where it is to where it needs to be is a rough experience, so our customers build tools and processes in an attempt to band-aid a suboptimal data movement experience, resulting in suboptimal insights, suboptimal actions, and suboptimal outcomes. Our customers end up working with subsets of data resources, working with outdated data, and missing out on key outcomes because of it. Now, we know that data movement performance drops significantly as distance between endpoints increases. This makes it difficult to plan and execute one-time projects, such as migrating to the cloud. This results in higher project costs and delayed cloud advantages. Now, for ongoing or recurring workflows, such as edge to cloud or prem to cloud data ingest, this latency impacted performance results in aged data, leading to less than optimal insights and overall delayed action. These issues plague our customers' workflows, unless they have a continuous data pipeline into the AWS cloud. Vcinity enables that continuous pipeline. Here's a scenario. A data scientist in San Francisco wants to run an analysis on a specific portion of a data set in New York. The analytics job takes 15 minutes to complete locally. This is a 1 terabyte data set on a 1 gigabit per second link. Using legacy tools, moving the 1 terabyte data set to a location where the scientists can do their work takes 16 hours, resulting in a total job time of 16 hours and 15 minutes. Using Vcinity as the data movement tool in that same scenario, the total time to move and analyze the data is reduced to 2 hours and 15 minutes. That equates to a lot less time waiting for your data to arrive and a lot more time you can spend using it. Anecdotally, we have a customer who expressed concern about the reduction of coffee breaks when he saw the performance that Vcinity brought to his team's workflow, which happened to be preparing and sending computational fluid dynamics data sets to their analytics systems over 3,600 miles away. Now, before we go any further, let's examine the high level of why Vcinity is so much faster. At Vcinity, we're all about the data. We've taken high-performance compute and storage networking technologies and stretch them to WAN scale, and the difference in net performance is huge. Generally speaking, for every 10 milliseconds increase in latency on a network, the end-to-end performance of that network drops by roughly 50%. Before long, legacy networks are using more of the network for overhead than actual data. Vcinity, however, uses an incredibly efficient protocol across the WAN that allows for up to 95% of the network to be used for actual data throughput, with minimal overhead, even as round-trip latency gets into the hundreds or thousands of milliseconds. This results in a LAN-like experience even at global distances. This high-performance solution enables an ongoing, hyper-fast data movement tool for our customers. Now let's dig a little bit deeper into how this works. Fundamentally, Vcinity creates a virtual lossless tunnel across a customer's wide area network. We do this with a bookend approach, meaning that each location in the customer's workflow would have some sort of Vcinity node on site. Could be virtual, could be physical, whatever's most appropriate for the customer's requirements. Between those two Vcinity nodes, we establish an RDMA, or Remote Direct Memory Access Tunnel, which is encapsulated in IP, meaning it will work across any Layer 1, Layer 2, or Layer 3 network. I mentioned earlier that we've stretched high-performance local networking to WAN scale, so in addition to the RDMA tunnel protocol, we also leverage buffer credits for traffic control to ensure efficient use of the network that's presented to us. We're also very selective with retransmits, so if some packets do get dropped along the way, we're able to retransmit at the packet level instead of having to drop everything in flight and issue a massive retransmit. Okay, that covers what happens between our nodes. Now to talk about integration with storage and compute. In those same Vcinity nodes that create the virtual lossless tunnel, we also leverage legacy protocols to interact with storage and compute systems. In the example in front of us, on the left side you see a network storage system with exports using native protocols, NFS and S3. On the right side of the screen, you see the destination, mounting the remote storage via local protocols to the local Vcinity node, NFS, S3, SMB. This target could be an AWS storage service or potentially cloud-native analytics tools. So we're creating an RDMA tunnel across the WAN, terminating native local protocols on each end, securing the connection between our endpoints, and we're doing all of this without modifying the data at all. No compression, no deduplication. Well, that's a lot of information. Let's turn the page and look at how we can bring this capability to our customers, enabling incredibly fast data transfer and improved governance for data into and around AWS. Now that you've seen the value this can bring to customers and how it works and integrates with other technology, let's look at some real-world performance metrics. We'll be reviewing performance in a few contexts: AWS workload validation, as well as Vcinity customer results, and lastly, AWS plus Vcinity customer results. So you're probably familiar with this, but to recap AWS workload validation refers to the process of testing and verifying the performance, scalability, reliability, and security of workloads, migration tools, or applications running in or to the AWS cloud. We've been fortunate to work with AWS to complete workload validation testing. The goal and purpose of the testing was twofold. One, determine whether Vcinity enables significantly faster movement of data into AWS storage services. And two, determine the effect of various dataset profiles on the time to move the data, validating the value proposition for small, medium, large, and mixed file sets. Within the test, we had two methods. The variable being data transfer across the WAN leveraging Vicinity's capabilities, and the control method being legacy copies using multi-thread Linux copy commands. The design for the testing was US coast-to-coast data movement between Vicinity's data center in Germantown, Maryland, and AWS US West 2 in Oregon, with a 2,800-mile gap between the two locations, working out to roughly 85 milliseconds of round-trip latency across a 10-gig wave. We tested with FSxZ and FSxN data stores, and used both NFS v4 and NFS v3 protocols. Now, for the more visual people in the crowd, here's a drawing illustrating the testing scenario. Storage source and layout on the left, with a storage target in AWS on the right. It's important to note that the Vcinity tunnel was configured at 4.5 gigabits per second across the 10 gig wave, while the traditional or control testing was allowed unfettered access to the full 10 gigs. Now, getting a little more granular with the testing data, you'll see some descriptions here. Very small files at 2 to 8 kilobytes, small files at 64 to 128 kilobytes, medium files at 5 gig, and a large file at 500 gigs, as well as a mixed data set that's a combination of all sizes. As you'll see later, those mixed data sets are key because those are what are often seen in many real-world workloads. Across all the tests, we wanted to measure 3 things. How long did it take to run the test for each method? Was there consistent performance across multiple runs? And what was the difference between Vcinity and traditional methods? So, to start off, when working with NFS v4 protocol and FSXZ data store, we observed significant improvement when using Vcinity, ranging from 1.7 times faster for medium and large files, all the way up to 76 times faster for small files, with the mixed file dataset clocking in at 6.4 times faster, which again is key due to how often we see customers using mixed datasets out in the wild. Running the same tests, but with NFS v3, which is generally more latency tolerant protocol, we still see incredible improvement in performance. 8.5 to 9 times faster on the smaller side and 4.5 times faster on the mixed file dataset. Now, focusing on FSXN, we observe a 14 times faster copy when using NFS v4 on the mixed dataset. And even with the more latency tolerant NFS v3 protocol, we still see a 4.7x faster copy when using Vcinity on that same dataset. Again, there's a lot of information, so let's quickly step back and review the takeaways. Customers can move their data much faster, enabling a continuous data pipeline. Now, through an analytics lens, this means you can curate your data in AWS faster so you can start modeling and driving results faster. Second, we saw consistent, significant improvement on mixed size data sets, which is the data profile most likely to be encountered. Third, we achieve much better utilization of the wide area network bandwidth. That's important because while we saw results with the tuned bandwidth, speeds to move your data could be even faster. That's key with analytics because the scale of data you have to move is significant for these workloads, as well as the time frame you need to move it in is an often particularly relevant requirement, such as for real-time analytics. And finally, we want to underscore that this solution creates a continuous data pipeline that can be used as a tool to support either finite migrations or ongoing routine movement of data into AWS. Now that we've seen some validation testing outcomes, let's see a few examples of how customers are using and benefiting from Vcinity out in the wild. First, we have a global cruise line who needed to improve their time to move a roughly 10 gigabyte data set. This is a recurring job that took approximately 48 hours to complete using their best technology and processes. With Vcinity, they were able to cut that down to just 90 minutes. Next, we have a Formula One race team with several data movement jobs, from internal IT needing to move large ISO files, as well as 600 megabytes of 1 kilobyte files. The ISO file went from a 2.5 hour job down to 60 seconds, and the very small file job went from 30 minutes down to 90 seconds. And in the life sciences space, a customer needed to improve the total time to ingest data into CryoSpark. Without Vcinity, it took this customer approximately 4.5 hours to ingest 500 gigabytes of files across a 1 gig WAN at 76 milliseconds. With Vcinity, that same process took just 1 hour and 22 minutes, or over 3x faster. Circling back to the Formula One team, this customer is now interested in leveraging the Vcinity capability to bring a tactical advantage to the track, enabling them to transmit data gathered at the track to the analysts sitting hundreds or thousands of miles away, so the trackside and remote analysts can collaborate on data in near real time with predictable, consistent performance, irrespective of the distance between the track and the analysts. Now, drilling down into a few key AWS plus Vcinity customer results, we see a media company who was able to use AWS's rendering services in Oregon with the data sitting in Los Angeles, over 800 miles away. This is important because they needed to keep highly sensitive data on-prem, but were still able to use AWS's rendering services to complete their work. We see an energy company who needed to migrate their data from their legacy data center into AWS over 1,500 miles away, so they could close out the space in their data center as quickly as possible and start using AWS as quickly as possible. Using Vcinity, they were able to get 4 times the performance over their existing processes, allowing them to exit their data center 3 months faster. In the public sector, we have a customer who needed to move data from their outposts in the US to S3 in Sydney, over 10,000 miles away. Vcinity enabled them to do this 7.5 times faster, allowing them to meet a mission-critical SLA. And lastly, we see another media firm who wanted to modernize their post-processing. They're able to have artists sitting in London access and operate on content sitting in Los Angeles as soon as the content is created. This also allows them to spin up new editors anywhere across the globe without worrying about distributing and monitoring additional copies of often highly sensitive content. So now we've seen a few customer examples out in the wild. Here are a few targets for leveraging this technology. Use cases, certainly data migrations for cloud adoption is a finite use case. For ongoing data pipeline initiatives, we look at data movement between regions or availability zones, ingesting data from the edge into the cloud, and aggregation or fusion or federation of disparate data sets for analytics, and backup and recovery between geodistant locations. For these use cases, our customers can expect to see faster availability of data and a more predictable performance of their data pipeline, irrespective of the distance between sites, resulting in improved efficacy of these analytics outcomes. These first two are particularly important for analytics workloads, as you'll see faster time to use the data and more holistic access, driving better, faster analytics outcomes. Our customers can also expect to see a reduced cost of migration due to faster movement of the data. Now, I mentioned at the top that for certain workflows, an analyst can operate on remote data without having to first move it. Let's unpack what that looks like. So going back to the example of the analyst in California working on a remote data set in New York. It took 16 hours to move it without Vcinity, 2 hours to move it with Vcinity, but what if the data stayed in New York? If the analyst runs that same job via Vcinity without first moving the data, the job may take a few percentage points longer to complete, but even if it takes 3 minutes longer to run, in this scenario, we've taken nearly 2 hours off the best case scenario for the total job time. Imagine that data set is a dynamic external table. Without Vicinity's remote access capability, that data set would have to be moved in order to use it. With Vcinity, that analyst can complete their work as soon as the data is created. This presents an interesting paradigm for the analytics space as it delivers 2 key points of value. 1, if you have a need for near real-time analytics outcomes, this technology enables you to operate on the data from anywhere, even as soon as it's created, so you can deliver those near real-time insights and action. And 2, with the scale and typical distribution of data you're curating, there may be cases where the data can't be moved. This technology breaks down data silos by enabling your models and analytics workloads to access data sitting anywhere, which means you aren't losing any of the value of that data. If we look at real-world numbers for remote analytics, we tested cloud-native analytics working with local and cloud-adjacent data versus remote data via Vcinity. Working with the data local in S3 and external tables sitting in the same data center, you can see the time to complete in seconds, various job profiles in the chart on the right. Now, if we move the external tables to the other side of the country, then ingest them via Vcinity, we're able to offer roughly the same performance as local, even though the data is sitting thousands of miles away. This means that we can immediately federate multiple data silos for cloud-native analytics jobs. I think this is pretty impressive. Now, we'd like to wrap this up with a demonstration of the Vcinity solution. Soon I'll be sharing 2 screens. Both are Windows clients sitting in AWS West 1 in Northern California. One has a gray wallpaper and has a mapped network drive from a share in US East 1, Northern Virginia, across AWS's global backbone at roughly 60 milliseconds. The other computer has a bluish wallpaper and also has a mapped network drive from the same share, but this client leverages the local NVPC Vcinity mount point to the remote data set. All the plumbing remains the same local area networks, the same wide area network, and the same latency. The only difference is the mount point. Having these clients side by side will help illustrate the difference between Vcinity and non-Vcinity configurations. The demo has 2 parts. First, a simple data movement. copying a file from east to west using a native Windows drag and drop operation, something we're all familiar with. The second part of the demo illustrates a workflow where the data remains at the source location, US East in this case, while it is consumed at the compute location, US West. All right, so here we have our two clients. Vcinity method on the left, traditional method on the right. Again, Vcinity method, the compute mounts the remote storage via the local Vcinity node at each side. Traditional method, the compute mounts the data directly across the WAN. So we're going to drag and drop a 10 gig file across the network and observe the performance difference. So we'll move, let's pick 10 gig 4. And we're going to see what we expect to see doing this across a latent connection. If you get close to the screen, you'll see that it says roughly 7.5 megabytes, which is about 56, 57 megabits per second. So very low utilization of the network. If we do the same operation with the same file across, again, all the same plumbing, we get 185, 190 megabytes per second, which works out to roughly 1.5 gigabits per second. So we're utilizing the network to actually move data as opposed to a bunch of overhead. So we'll let this 10 gig job finish. We probably won't let this one finish, but during the demo, we are doing a simple drag and drop workflow to illustrate performance. You may have seen the term AccessX during the presentation. That's the built-in data copy and movement tool that's part of the Vcinity solution. This tool can be used in a browser-based GUI to copy or move data between sites. It can also be used via API for integration into workflows. So as this one finishes, we'll go ahead and end this one so we can move on to the second part of the demo. So what we're going to bring up is a seismic data viewer called OpenDetect on each machine. And here's the part where we're going to consume remote data without first moving it. So if you look here, you'll see these elements, right? These add up to roughly 12 gigabytes. And we want to just open a subset of that. It's about a 4 gigabyte subset called the 3D horizon data. So this data, again, is in the east in Ashburn, and the compute clients are in the west in Northern California. So what we're going to do is just click add to load in the data, and we'll observe even just the few seconds it takes to bring up the window with our selection. We'll hit the check mark to select all of these data points in the 3D horizon, and we'll have to come back to this because this hangs for quite a while. We move to this the Vcinity method, perform the same exact actions. You'll notice right away we get our pop-up. I hit the check mark to select all, and within just a couple of seconds we get all of the check marks. I hit OK, and immediately we start visualizing data into the viewer. Now, I haven't made a local copy for this to work. I haven't pre-cached anything. This is the application calling the remote data directly into application memory. And at this point, I can start working with the data, creating models, running analytics jobs. If I needed to add other data points in, I could go in and add, in this case, well data or so forth. On the right side, we're still waiting for the application to respond. It's hung for a little bit. Oh, look, we get check marks. I hit OK. This generally takes about 3 or 4 or 5 minutes to process. So we take a job that would take 4 or 5 minutes, maybe total, down to just a few seconds. But generally speaking, companies would have to move this entire 12 gigabytes of data just to be able to look at 4 gigabytes of it. Whereas with Vcinity, we can point the application directly to the remote data and load it without having to first have a local copy. We've covered a lot of ground today. To summarize, we can help our customers turn their data into a differentiator. Using Vcinity to enable a continuous data pipeline, our customers can quickly transform their most important assets into improved action, innovation, performance, revenue, as well as other advantages. So we'd love to connect with you. Feel free to reach out to our AWS Alliance Director. We'll work with you to identify customer use cases and make a plan to unlock the full potential of their data. Thank you for your time. We look forward to working with you.